What I will do in this video is to go over some techniques and strategy for doing a module practice test. So this is module 1. There are 20 questions, and it states here clearly that this test will affect your study plan score. So the way MathLab is set up, if you miss an item and you already have mastery for it, you lose that mastery point, and it directs you to go back and review this, which is a very positive thing to get you to be sure you know mastery of that topic, so when you do take the test, you get it right. And I will help you with strategy here as well. And if you look over on the right, you see a number of flags which are all prerequisites, things you must do. And generally it's to earn at least a 70% on the module test you're taking so that you can move on to the next one. Alright, well, let's get started. Now, I'm not going to give you the answers, but I will give you strategy for getting the answers. So here we're asked to simplify this fraction. We note we have a negative in the bottom and a positive on top, so our answer will be a negative. So keep that in mind. Now you're going to divide the 2 into 10. That answer will go up there. You're going to move an exponent across this division bar, and it changes its sign. So here it's positive. When it goes up here, it's negative. So 9 minus 5. Now keep in mind that on this G, where it appears there isn't an exponent, there's actually a 1 there. So this 1 comes up to the top and becomes a negative 1. And that will be your answer. Now here, they do not want negative exponents, so you are dealing with them here, so you need to do some conversion. Now remember, you can change an exponent sign just by moving it across this division bar. Now let's look at some strategy here. So here this is to the 3rd power. So one of the first things I would figure out is what will be my sign of this overall expression when we finish. Well, raising anything to the 3rd power, if it's negative, will result in it being a negative. So we now have determined the sign of the whole expression. Now here we have a 1 by the 2, and we have to multiply when we're raising powers to a power. So this is going to be 2 to the 1st, and then that 1 times a negative 3 will make this 2 to the negative 8. I'm sorry, 2 to the negative 3. When we bring it down, so if we put it up here, let me see, try it this way, 2 to the negative 3. When we bring that down to our denominator, this is going to be 2 to the 3rd, which makes it an 8 down in the denominator there. So we can erase that for now. Now the others, it's going to be G to the negative 4th times a negative 3 makes this a positive 12. So this G is going to stay up on top. And then we have H to the 3rd times a negative 3. This combination will make it a negative 9 up on top that needs to be brought down to the bottom. And that's the strategy for this. The strategy for this is actually, this is in scientific notation, and this is in scientific notation. So the rule is we multiply this part by this part, and I'm going to get an answer. And I'm just going to make one up here. This is not the correct answer, just to show you the technique. But when you multiply, you get a number. For instance, it might be like this. That's not what you get, but this is an example. Then you will work on your exponents, powers of 10, where you just add them together. And this one is going to be, let's say, we can actually do this one, a negative 10. So we're just adding the exponents. Now this is what you get, but this number now is not in scientific notation. It has a number greater than a number between 1 and 10. So what we need to do then is make this into scientific notation by moving the decimal point right there. So we now have 1.2367 times 10. But now since we move the decimal one place to the left, we have to add a positive 1 exponent to this. So this now becomes a negative 9. Now the question is, if you put this into MATLAB, would they accept that? And the answer is no, they wouldn't, because you have to use the correct number of significant digits. And we went over this in class. This item has 2 significant digits. This one has 3. So following this order, we must reduce our number of significant digits to the least number of significant digits, which is 2. So we can only have 2 here. So what we look at in this case would be this digit. If it were 6 or more, 5 or more, we would add 1. But since it's not, we just drop all this, and our answer then becomes 1.2 times 10 to the negative 9. Now this is not the answer to this example, because this example doesn't give you this when you multiply. I'm just giving you that as a thumbs up. Now in this example we're getting an equation. So the strategy, again, neatly, combine like terms, 6y plus 32. Combining this, remember there's a 1 there. And then we're going to go combine these like terms, 2y equals 40. Then we can transpose and eventually solve for y. So not too much strategy other than knowing how to solve an equation. And I see I needed to put a plus there. Again, I got carried away. Okay. For something like this, when you have the letter you're looking for in 2 terms, we have to factor it out. So u s plus v equals x. Now to isolate the u, we have to divide both sides by this. And then this cancels out, and that's what u is. Now note that all of these are lowercase letters. So if you make any of these letters capital, they will count that incorrect. Now for something like this, they want you to use these letters, M and N. So they're saying the difference between two numbers, and you must use these letters, and then it's going to be 19 less than that you're going to put up here as your answer. Again, I don't want to do these, but this one's very close. Now, some background of this is we want two consecutive even integers. So if we thought, let's say 8 and 10 would be two consecutive even integers, and 8 would then be x, and 10 would be x plus 2. So algebraically, this is how you would write two consecutive even integers. And then they're saying such that 2 times the first, that would be 2x, and 3 times the second, and the key here is you have to put this in parentheses to be 3 times the second translates to equal 46. So from this background you are to write the equation, and notice they're saying do not combine like terms, do not simplify, and the 46 is already there. So just write this part in the box. Now for this, here they're going to ask a number of questions. For instance, our first thing is if f of 3, which is in a sense f of x, they're saying that our x value is 3. So we go over to our graph where x is 3, which is right there. And what is our y value as it crosses that line there? And that's a -1. Now a little later they're going to ask us for letter C here, if, remember, this could be written as y equals 2, so we put a 2 there. So y equals 2 where? Y equals 2 right there. And what do we have for our x value? At this point, we have a 6. Okay, and they're then going to ask us for what is the domain. Domain are our x values. So we move this up to the x line and put a bracket there. That will be a 1. Drop this down to the x value, and that is an 8. So if you were to put that in interval notation, this one specifically will be a 1, 8. And if they want that in set builder notation, you have to pick it out where this is the case. I'll let you do that. Now for the range, which are your y values, it starts here at -9. Again, reflecting this line over to the y-axis and going up to 8. So the range in interval notation will be -9, 8 bracket. And again, they will probably ask you for that in set builder notation, where in a sense you just put like the x in the middle, or in this case it's the y, and here it's the x, and then use the appropriate signs as you can see from this. Okay, next one. This one you have a couple of things that you'd want to do. For this one, what value of x would make this denominator a 0? Well, it would be taking your denominator, equaling it to 0, and get an answer. And that's the value of x that would make the denominator a 0. So that has to be excluded. So looking at your multiple choice here, this is sort of an easy one. Now, for this one, you have a system of equations, and you want to find the ordered pair where they would intersect. Well, they're saying use the substitution method. So the strategy would be 4x plus y equals 14. So we solve for one of the letters. Y equals a negative 4x, just transpose that, plus 14. You then take this value and put it in the other equation where y is. So it then reads 3x minus 3 times a negative 4x plus 14 equals 3. Now you have an equation with only one letter. You solve for x, and x will be something. Now when you find that value, you then put it into either of the equations, and then you find out what y is. And you put that there as an ordered pair. And there is a tool for that. Now, for this one, they're asking to use the elimination method. And you'd write these out nice and big. Now, I notice here we have a negative 9y. If this were a positive 9y, these would cancel out. So I'm going to modify this equation by multiplying each term by 3. So here this becomes 3 times 7x, 21x. 3 times 3y is a positive 9y. And 3 times a negative 24 is a negative 72. Now I put my line, and I just add them up. So I guess I can do this part. Remember, there's a 1 there, so this is 22x. Here these cancel out, which is the elimination method, and this becomes 132. And now you will solve for x. Once you get an x, you take this value, I would put it probably in this one, and then solve for y. And I forgot to bring the negative sign down. Be sure you do, so that when you do your division, you get a nice answer. So again, strategy for something like this would be to look at it. This is sort of in standard form. Now, here you want to line up your letters so that when you do, an interesting thing happens. And let me just give you some background. If you end up with something like 3 equals 3, or 0 equals 0, these are true statements. So for that, it would be letter B. There's an infinite number of solutions, and you would write that in set builder notation, one of the equations. But if you ended up with, let's say, 0 equals 5, then these lines are parallel, and that would be no solution. So again, an interesting thing as you work on your technique for solving systems of linear equations. Now, for something like this, as you look at it, you might say, well, what can I do here? And they're allowing you to brainstorm. So one suggestion I see in the second equation, if I divide everything by 3, I get this. So now if I solve for A, I transpose that and I get 5b plus 2. So I can take that now and go where A is in the other equation, and I can use substitution. Or I can multiply this one by a negative 5, and this would become a negative 15a each term, and these would cancel out. So this is a strategy, and you can use whichever method you like. Now this comes out as fractions, so that's the little challenge, but again, you can miss one, and that's no problem at all. You just need to earn a 70 on this. So for something like this, you'd have to set up systems of equations, and you'll identify the types of seats. We can say pavilion seats, we can use the letter P, and lawn seats, we use the letter L. Or you could use X and Y, either way. So we know that the number of pavilion seats plus the number of lawn seats were 1,600. Now pavilion seats are $30. Lawn seats were $20. And the total revenue was $40,000. So, again, a strategy might be you're going to multiply this equation by a negative 30. This way the p's would cancel out. And whichever method you use, it's just a process of being careful, watching your signs, and then later substituting once you find a value for p for L. Again, pause the tape if you need to read something more slowly. Here, this will be cornmeal. We'll use the letter C. It's 12%. And this one will be, well, let's change that a little bit. So, soybean, yes. We'll use that as an S, and cornmeal here. Sorry about that. And we're going to have this mixture. So S plus C equals 240, and you have 12% here plus 6% equals, you want to end up with an 11% of a mixture that is 240. And there are your equations. A suggestion would be to get rid of your decimals each term, and then if you're going to use elimination, you would multiply this equation by a negative 12 each term, and then the s's cancel out, and you solve for C, and once you find C, you substitute it, let's say here, and solve for S, and those would be your answers. And let me caution you that here they're asking for cornmeal, so this would be the 6%. So a little bit different orders. You have to be careful where you put your answers. Now, as a reminder, you might consider using your calculator and using that matrix technique to check your answers. Okay, let's take a look at this. We have a fellow that's traveling upstream with a current to reach a campsite, then returns against the current. So for this, I believe we'd be using the distance formula. Distance equals rate times time. So let's make a little picture. So again, we know the distance is the same. So in a sense, it's distance equals distance. And distance is rate times time. Rate times time. So the rate going with the current was r plus 3, and it was time is 4 hours. Going against the current was rate minus 3, and it was 7 hours. So your equation would be 4 times r plus 3 equals 7 times r minus 3. And we'll let you solve that. And that will give you your rate in still water. Some background on this is you solve these inequalities. Just transpose that and you get a negative 14. Transpose that and you get a negative 15. And then putting this on a number line, here you're going to use a parenthesis. And remember, it's greater than, so the parenthesis faces this way. And here you're going to use a bracket. And it's less than, so it's going to face this way. But this is an or statement. Or is a union. So all of this has to be included. So what does your graph look like once you do that? And then converting this graph to interval notation. And I can help you with this one a little bit here. So this is going to go this way. This is going to go, let me see here, 14. No, I got that back. Yeah, that's good. 15 goes, got the wrong signs here. Parenthesis this way. Bracket this way. There we go. So notice it's all filled in. So what would be the interval notation for all real numbers? That's what you have to put here. And then pick out the right graph that reflects this. For this compound inequality, we have to isolate the x in the middle here. So we're going to add 1 there, add 1, add 1. Get this, and now we're going to divide everything by 2. And we're going to get x in the middle. We'll let you finish that. And then what will be the graph? Well, remember, this sign is going to be a bracket, and this sign is going to be a parenthesis. So you need to pick out the correct graph here. Then once you have the correct graph, which I do, you have to put it in set builder notation and then interval notation. So a lot on this one. So in this case, just a review of set builder notation right from the graph, and then now you're going to put that in interval notation where we use a parenthesis for this one, -4, comma, and then 4, +4, with a bracket. So I gave a little bit extra on this one, and of course as you get these examples, they're similar, but the numbers change. You just have to do the specific example they give, but this is showing you how to write the answers. So the strategy for this one would be remove the absolute signs and just write it regularly and solve it for x. And this one, remove the absolute signs, but this value could be a negative x, that is opposite sign. And the tricky part is if you had something like this, absolute value of 4x minus 5 equals initially a negative 8. That there is no solution for that if initially with the absolute signs there's a negative 8 there. So that would be an empty set. But that's not what we have here. Okay, so you're just going to solve that, put your answers in here, separate them with commas. So the strategy for this next one is, before you start to calculate, just transpose that. Becomes a negative 4, and this gives you a 5. Now take this and write it, and then reverse the sign. Should probably change color there to emphasize. And this is a negative 5. Okay, so you solve these, and notice we said anytime you had absolute value is greater, this was going to be a disjunction. So your solution set is, and you have to type it in interval notation, and since it's a disjunction, you'll probably use this sign right there. So you've worked pretty hard during this test, so let me help you with this one. X is greater than 8, x is greater than 8, x is less than negative 2, x is less than negative 2. Interval notation is coming from negative infinity up to a negative 2, parenthesis, then union, parenthesis, 8, comma, positive infinity, parenthesis. Okay, so we're going to write this interval notation there, and then later select our graph. Okay, hopefully this is helpful. It did take a little over 30 minutes just to give you the strategy, and good luck.